Hi Chem students, today we'll be talking about ions. Please get out your notes and turn to page 5. Have your periodic table ready. Last time we talked about valence electrons. Now we will go in details of the role valence electrons play in the formation of ions. An ion is a charged particle that forms when an atom loses or gains electrons. Atoms lose or gain electrons in order to bond with other atoms and become more stable. Remember from the atomic unit that atoms are neutral because the number of protons, which are positive, is equal to the number of electrons, which are negative. What happens when protons or electrons are not equal? Well, this would mean that we have ions which are charged because the number of protons is no longer equal to the number of electrons. When an atom loses electrons, this results in a positively charged ion called the cation. The T in cation looks kind of like a positive. Another cute little trick is that cations are positive like the paws on a cat. And when an atom gains electrons, this would result in a negatively charged ion called the anion. And since there's no neat trick to remember this, just remember that the cation is positive and the anion is the opposite of that. Here we have an example of a sodium atom which has 11 protons and 11 electrons, which make it neutral. If the sodium atom then loses one electron, then its charge would be +1, because then it has 11 protons but only 10 electrons. So the sodium ion will still have 11 protons, which are positive because the element hasn't changed. But since it has lost one electron, now it only has 10 electrons. When you have +11 and -10, the overall charge of it would be +1. Now let's review over the concept of losing or gaining electrons, and specifically how many. A quick tip while doing this is to remember that electrons are negative. So if the ion is negatively charged, it has gained electrons. It is a positively charged ion, therefore it has lost one electron. The chlorine ion is Cl-1, and since it is negatively charged, it has gained one electron. Magnesium ion is +2 by losing 2 electrons. Nitrogen is -3 by gaining 3 electrons. Now I want you to quickly pause the video and try oxygen and aluminum. Welcome back. Oxygen is -2, so it has gained 2 electrons. Aluminum is +3, so it has lost 3 electrons. A very helpful pattern exists with the representative elements. So that you don't have to remember these charges, make sure to annotate on your periodic table so you can quickly find the charges. In chemistry, we call columns groups. So for all elements in group 1, their ions would have a charge of +1. All elements of group 2, their ions would have a charge of +2. Then we're going to skip the D block because they have various charges. Group 13 ions would have the charge of +3. And then we're going to skip group 14 because once again we have various charges. Group 15 is -3, 16 is -2, then -1. Remember, these ion charges applies to all elements within the same column, in which case we call group. Group 18 elements are the noble gases. For our purposes, they do not form ions because they're the most stable. From groups 3 through 12 and 14, ion charges can vary within the group and even vary for one metal. Example, sometimes copper is +1 and sometimes it is +2. So we cannot assign a charge for these groups as we did above. We will go into this in more detail later. However, you must memorize the charges for these 3 ions. They will always be the same and you are expected to know them for this class. The silver ion, or Ag, is +1. Zinc is +2, and Cd, which is cadmium, is +2. These are located right here on the periodic table. Make sure you label them. Formulas and charges for polyatomic ions can be found on the back of your periodic table. The only one that you will have to remember is for the phosphite ion, PO3, 3-. Therefore, its charge is -3. It is not on the back of your periodic table, so I would advise you to write it down. The rest are there for you to use. Let's talk about ions and electron configuration. If atoms lose or gain electrons in order to become ions, then electron configurations for ions must be adjusted based on the number of valence electrons lost or gained to form the ion. Right now, your periodic table should have these ion charges labeled for each group. And then for the special noble gases, they're going to have a charge of 0. So there is a reason why this pattern exists for these ion charges. And it is based on valence electrons. Now take a moment and pause the video if you have to. Check your periodic table that you have these valence electrons annotated for each group. Helium is in group 18, so column 18 on the periodic table, because it is a noble gas, but it only has maximum 2 electrons. These noble gases, just like their name, has a special status and stability that all other elements want to achieve, and that is 8 valence electrons. You will see in a moment that elements will lose or gain electrons in order to achieve the ultimate 8 valence electron status. Let's start with our first example, calcium, which is in group 2 and it has 2 valence electrons. Calcium now has 2 choices. Since it already has 2 valence electrons, it can choose to gain 6 more valence electrons, or it can try to lose 2 valence electrons. Well, you may be wondering, if it only has 2 valence electrons, what happens when it loses both of them? Well, then instead of having 2 valence in the 4th energy level, calcium is going to have 8 valence in the 3rd energy level, which is completely fine. It still has the 8 valence electron status. Therefore, it is easier for calcium to lose 2 than to gain 6. And since it's going to lose 2 valence electrons, its ion formula would be Ca plus 2. Let's look at oxygen, and it has 6 valence electrons as represented by its electron dot structure. Now, oxygen has 2 choices. It can either gain 2 more valence electrons to achieve number 8, or it can lose all 6 of its valence electrons. So is it easier to gain 2 or to lose 6? Of course it is to gain 2. Elements will always take the easier way. So if it gains 2 electrons, its ion formula will be oxygen, or O, minus 2. Next is aluminum, which has 3 valence electrons, and once again, it can either gain 5 valence in order to achieve 8, or lose all 3 of its valence. And of course, the easier choice is to lose 3, and its ion formula will be Al plus 3. Fluorine has 7 valence electrons. It can either gain 1 valence to achieve 8 or lose all 7 valence electrons. And of course, it's going to choose to gain 1, and therefore its ion formula would be F negative 1. Potassium has 1 valence electron. It can gain 7 or lose 1. Losing 1 is the easier choice, and its ion is K plus 1. Lastly, we have nitrogen, which has 5 valence electrons. It can either gain 3 to achieve 8 or lose 5. Easier to gain 3. Therefore, ion is N negative 3. Remember, this is the reason why this pattern exists for the ion charges. Elements will always lose or gain in order to achieve 8 valence electrons in the easiest way possible. Now, for each of the elements mentioned in the previous table, we're going to write the electron configuration for the atom, and then adjust the configuration for the ion by losing or gaining the proper number of valence electrons. This is the full electron configuration for calcium. Remember, valence electrons can be found in the highest energy level, which in this case is the 4th, and calcium has 2 valence electrons. From the previous table, which I have inserted here, we said that calcium would lose its 2 valence electrons in order to achieve the noble gas status. So if both of these electrons in the 4s go away, its ion won't have a 4s level anymore. So for the ion Ca plus 2, it would end at 3p6 because it has lost 2 valence electrons. For oxygen, Its highest energy level is the second energy, which includes two sublevels, S and P. On the previous table, we said that oxygen would gain 2 electrons. Therefore, its ion is going to gain 2 more electrons in the P sublevel of the second energy level. This is because the S sublevel is already filled up. So the oxygen anion, O-2, is going to have 6 electrons in the 2p. Aluminum highest energy level is the third, and we said it would lose 3 valence electrons. Therefore, these would go away, which would leave us with an aluminum cation of Al plus 3, ending at the second energy level, 2p6. Fluorine has 7 valence electrons in its second highest energy level, and previously we said it would gain 1, therefore adding 1 to its p sublevel, leaving us with fluorine anion, F-1, with 6 electrons in the 2p. Now I want you to pause the video and try it for potassium, which is K on the periodic table, and nitrogen, which is N. Welcome back. Potassium will lose its only valence electron in the fourth energy level, creating a potassium cation, K plus 1, ending at 3p6. And nitrogen, which will gain 3 valence electrons to achieve 8, will fill up its 2p, going from 2p3 to 2p6. Finally, you can check your work. They all add up to 8 valence electrons, so yay! These ions have reached the same valence electrons as noble gases. Now we're going to put our skills together to illustrate what happens when atoms become ions. Ionic compounds form when a metal loses electrons to a nonmetal, and the resulting oppositely charged ions attract. With your teacher's assistance, make electron dot diagrams for the following pairs of elements, showing how their electrons transfer to form the compound. Our first example involves calcium, which is a metal, and fluorine, which is a nonmetal. Calcium has 2 valence electrons, represented by these 2 dots. Fluorine is in group 17. Therefore, it has 7 valence electrons. Well, what happened during ionic bonding is that calcium is pretty unhappy that it only has 2 valence electrons. It would like to have 8 valence electrons, but that would mean gaining 6 more. So therefore, the easier choice is for calcium to lose its 2 valence electrons. When fluorine comes along, it only needs 1 more valence electron to achieve the happy number 8. Calcium will happily donate 1 of its electrons to fluorine, making fluorine very happy. Now calcium is still unhappy because it still has 1 more valence electron left. Therefore, it would need 1 more fluorine to come along so that it can donate the last electron to make the second fluorine happy. During this electron transfer, both fluorines now have 8 valence electrons, and calcium has managed to get rid of both of its valence, so they're all happy. The final compound that comes out of this electron transfer is called calcium fluoride, with the formula CaF2, which means 1 calcium ion and 2 fluorine ions. This is an ionic compound because when these atoms interact, they transfer electrons to thus becoming ions. Let's do this again for sodium, which is a metal, and nitrogen, which is a nonmetal. Sodium is in group 1, therefore it has 1 valence electron. Nitrogen is in group 15, which means it has 5 valence electrons. During electron transfer, sodium will be very willing to give its 1 valence electron away to nitrogen. Nitrogen now has a total of 6 valence electrons, but it's still missing 2 more to achieve the 8 valence. So what ends up happening is you have another sodium atom comes along, and it's going to give its 1 valence to nitrogen, and now nitrogen has 7. And then a third sodium atom shows up and gives its 1 valence electron to nitrogen. Now with these 3 sodiums donating their electrons, nitrogen ends up with a total of 8 valence electrons. And now they're all happy. The final compound that comes from this interaction is called sodium nitride. The formula is Na3N, and this is an ionic compound because the atoms involved have given or received electrons in order to form bonds. Now go ahead and try one on your own. Welcome back. Hopefully you were able to figure this out.